Okay, how's it, Chase? Good to be back. You'll probably only be watching this video in a little while, but I've been making these day after day, so it's kind of like I'm back at varsity studying every day, doing some maths. But yeah, that's enough nonsense talk. Let's get into it. In the previous video, we finished on that exercise 5.1. I finished on example 22. Or question 22. I'm going to try get through the rest of that in this video and hopefully start. Let's take a look. We can do a little bit of work on the circle, which there's far less detail in that chapter than on the straight line graph. But okay, without further ado, let's get back into it. I'm going to... Okay. 23. With these videos, feel free to, even though I'm doing the problems now, feel free to, when I say example 23, stop and do the example first, and then watch my explanation of it to make sure you understand. I think that would be the most beneficial way for you to do things. That way you'll learn the most, because you can see what you don't understand, and then watch that section of the video, and then you'll see how to do it and see the explanation. So for 23, it says, it gives the equation of a line in point gradient form, and says calculate the gradient of the line that is perpendicular to this line. So what you're going to do there is just multiply everything out, get it into gradient form. Excuse me. Get it into gradient form, which is y equals mx plus c. Okay, and once you've got it into gradient form, then just find whatever number is sitting here and use, for perpendicular lines, we know that m1, m2 equals minus 1. So just use that and find the gradient of the line that's perpendicular. Okay, 24. It says calculate the equation of straight lines with gradient. Gradient equals 3 over 5. This is 24a, by the way. Gradient equals 3 over 5. Y-intercept is equal to 2. This is very easy. If we just use our, because they don't say what form to put it in, so if we just use our gradient form, y equals mx plus c, m is given as 3 over 5, so it's 3 over 5x, plus the y-intercept is c, so that's just 2. Done. Same for 24b. Very easy. Okay, question 25. You've got a whole bunch, a, b, and c, so let's just quickly do b. Okay, 25b. Calculate the equation of the straight lines with the following x and y intercepts. Give the answer in general form. Okay. Oh, okay. Alright. Okay. So here, for B, so they say, get the equation of the line. Equation of the line in general form. Okay. And they tell you that the x and y intercepts are as follows. Okay, so the x and y intercepts are, and they give you two sets of points, which confused me for a little second there as well. So A equals and B equals. Okay, so A for B is -3, 0, and B is 0, 4. So obviously your x-intercept, if you plot these 2 points, -3 and 0 is there. So there's your x-intercept, it's at -3, and plot the point 0, 4, which lies here. So that is obviously your y-intercept at 4. Okay, so we just use the intercept form, which is x over a plus y over b equals 1. Okay, and we know that a, which is our x-intercept, is minus 3. B is our y-intercept, which is 4. So, substitute in x over minus 3 plus y over 4 equals 1. Okay, now to get it into the general form, which is ax plus by plus c equals 0. Okay, so let's start multiplying through by these denominators to get rid of them. Okay, so let's multiply through by negative 3, and we get rid of that. So that gives x plus x minus 3 over 4y equals negative 3. Okay, then let's multiply through by 4 over 3, which will get rid of this over here. Okay, so next we're going to multiply through by 4 over 3, because 4 over 3 times 3 over 4 equals 1. Right? So let's do that. So 4 over 3x minus y equals minus 3 times 4 over 3. Okay. Let's carry on simplifying. 4 over 3x minus y equals negative 4. Okay. I think your book doesn't like having a fraction here, so they want the a to be an integer. So let's just multiply through by the denominator here so that we've got an integer in front of the x rather than a fraction. So if we multiply the whole equation by 3, we get 4x minus 3y equals minus 12. And now remember, we need a 0 on the right hand side, so we just take that across. 4x minus 3y plus 12 equals 0. There you go, you've got the equation of the line in general form. Okay. Okay, so for 26, I'm going to do number B. Okay, so they say it passes through the point minus 3 and 2 with m equal to 4. Okay, so we've got a point, we've got a gradient. So what do we use? Point gradient form. Y minus y1 equals m into x minus x1. Easy stuff. Substitute in m. We've got x1 there, we've got y1 there. Y minus 2 equals 4 into x minus 3, which is x1. Y minus 2 equals 4 into x plus 3. Then we multiply out and leave it in our gradient form, which is y equals mx plus c. Okay. Because they didn't tell us to leave it in any specific form, so we use this one. Okay. Y minus 2 equals 4x plus 12, so I'm just multiplying out. Y equals 4x plus 12 plus 2, so I took the 2 across to the right hand side, and y equals 4x plus 14. And there you go. There's the equation of your line. I'm not going to do C and D, but just note for C, what you can use, because there they give you a point and they give you an angle of inclination, theta. So in order to get your gradient, you're just going to say m equals tan theta. Easy stuff. And then you'll have your gradient and you'll have your point, and you can do the exact same thing. Okay, let's do 27. Find the equations of the lines passing through the following 2 points. For 27, I'm going to do number C. They give you the 2 points as okay. And seeing as they've given you 2 points, what form are we going to use? We're going to use 2-point form. And let's just go find the formula for the 2-point form. There we go. Okay, 2-point form. This formula you'll probably find on your formula sheet. I'm not sure. You'll have to check that. Otherwise, you can know it. You don't. There is a way to do it without the 2-point form, but I think we're just going to stick to your book's method and make everyone's life easy. So 2-point form is y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. So we can substitute the values in, and then we leave it in gradient form because they didn't ask for any other form. So leave it in gradient form, and we know by now that that is y equals mx plus c form. Okay, so let's substitute in. As I said, you can choose either point as point 1 and the other one as point 2. So this could be 1, this could be 2, or this could be 1 and that could be 2. Doesn't matter, I'm just going to use this as point 1, this is point 2. So we have x1, y1, x2, y2, and we can substitute in and simplify it into that form. So let's do it. Y minus y1 is 2 over x minus x1 is negative 1 over y2 minus y1. y2 is 8 minus y1 is 2 over x2, which is 2, minus x1 is minus 1. Okay? So let's simplify and get it into that form. So y minus 2 over x minus minus 1 is x plus 1 equals 8 minus 2 is 6 over 2 minus minus 1 is 2 plus 1 is 3. Okay, so now we got y minus 2 over x plus 1 is equal to 6 over 3 is 2. Okay, then let's take this whole denominator across to that side and multiply. So we're left with y minus 2 equals 2 into x plus 1. Okay, y minus 2 is equal to 2x plus 2. Now we're going to take that 2 across. Y equals 2x plus 4. And there you go. That is question 27. Let's find some blank space so we can carry on. Okay. And all of question 27 fairly similar to that. Question 28. They say write down the gradient, so find the gradient and x and y intercepts of these lines without drawing them. Okay, and I'm going to do 28C. And they give you the lines in general form. So 2x plus 3y plus 4 equals 0. So in order to find the gradient, we need to convert this to gradient form, or y equals mx plus c form. In order to find the x and y intercepts, we could then convert again to the intercept form. But that's very tedious, so I'm going to show you another way to do it. So let's convert to gradient form quickly. And remember that is y equals mx plus c. So we just need to solve this equation for y. So let's take the x and the constant across to the right hand side. 3y equals minus 2x minus 4. Then we're going to divide by 3 so that we have y by itself on the left hand side. So y equals minus 2 over 3x minus 4 over 3. Okay, easy stuff. And now, because it's in y equals mx plus c form, we already know the gradient. So we've got the gradient. M equals minus 2 over 3. So we're halfway there. Now we need to find the x and y intercepts. Okay, so as I said, we could do all the effort to convert it into intercept form, but let's do it a different way. And this is a rule for straight lines. To find that, use this form to find the x-intercept. Let y equal 0 and solve for x. Okay? And to find the y-intercept, so this is to get the x-intercept. Let y equal 0 and solve for x. To get the y-intercept, let x equal 0 and solve for y. Okay, so let's start off to find the x-intercept. I said we let y equal 0. And just in case you're wondering, why are these the two rules? Well, if you look at a straight line, let's draw a straight line here. Do you agree that this point here, this is our x-intercept? Okay, so what is the value of y when the line is crossing the x-axis? It is 0. And that's why we let y equal 0 to solve for the x-intercept. Similarly, for the y-intercept, which is this point here, look at the value of x. The value of x here is 0. Okay, so that's why to get the y-intercept, we let x equal 0. Okay, so let's solve for our x-intercept. So we're just going to take our equation and let y equal 0. So substitute 0 in for y and solve for x. 0 equals minus 2 over 3x minus 4 over 3. Okay, so let's take this across. 2 over 3x equals minus 4 over 3. Then we're going to divide by the whole equation by 2 over 3, which is the same as multiplying by 3 over 2. So x equals minus 4 over 3 times 3 over 2. X equals minus 4, 3's cancel. X equals minus 4 over 2 is equal to minus 2. So our x-intercept is minus 2. We can write that as an ordered pair as minus 2. So x is minus 2 and y is 0, because we let y equal 0. So y is 0. Okay. Now let's solve for our y-intercept. Y-intercept. And we're going to do the same thing except let y equal 0 here. Let x equal 0. So we're solving for the y-intercept. If you look at the graph, by the y-intercept, x is 0. So let x equal 0 in the equation and solve. So y equals, let's take our equation. so for the y-intercept, let x equal 0. And in an exam, feel free to write this. Say y-intercept, therefore let x equal 0. And then write your equation and solve. So, let's take our equation, which is y equals minus 2 over 3 x minus 4 over 3, and let x equal 0. So, y equals minus 2 over 3 times 0 minus 4 over 3. This is 0. So, y equals minus 4 over 3. And therefore, that is our y-intercept. Okay, and to write that as an ordered pair, we've got, in the function, we let x equal 0, so we've got 0 on our x coordinate and minus 4 over 3 on our y. And there you go. Done and dusted. Okay. Okay, question 29 is a little bit interesting, something a bit different. They say draw straight lines of the following equations on a single sheet of graph paper and give the domain and range of each one. Okay, so unfortunately I can't just put graph paper on my screen here, but I'm going to draw some axes here. 4 and 5, and this is my y-axis, and this is my x-axis. Remember to label all of these things when you're doing this in an exam. Minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4. Minus 5, minus 1, minus 2, 3, minus 4, minus 5. Okay, so the first equation is and we can use our colors quite nicely for this, make everyone's life easy. Okay, so for part A, the line is x equals 2. So, how do we draw that line? It's the line where x equals 2. So that line looks like this. Of course, draw it with the ruler because it's supposed to be a straight line. And there you go. And I would label your line, so call it x equals 2. Okay? The second line is the line y equals 3. So we go to where y equals 3. Right, let me write that down for you. B, the line is y equals 3. So go to where y equals 3 and draw your line. Remember to put arrows on the end of these lines because these lines actually extend forever in the directions they're going in. They extend forever. So that's the line y equals 3. Okay. C is y equals 2x plus 3. Okay. So we already know that the y-intercept is 3, so let's draw that point there. We also know the gradient is 2. Which means it rises 2 for a run of 1, meaning that every time x increases by 1, y increases by 2. So if we go 1 across, y must go 2 up. So we've got a point there. Okay, and if we go down by 1 on our x, we need to go down by 2 on the y. So if we go to negative 1, we're going to drop 2 on the y-axis. Okay, and there we go. If you had a ruler, this would be a really nice plot because you just draw a straight line through these 3 points, and there you have it. Okay? And also they say, for C, they say show the intercepts. Indicate the intercepts. So here, we can indicate this intercept. That point, we just label it as, what point is it? X is 0 and y is 3. And we get that from here because it tells you our y-intercept because it's in gradient form. So there's our y-intercept, it's 3. Okay, to get the x-intercept, how do we get the x-intercept? let y equal 0 to get our x-intercept. So 0 equals 2x plus 3, and if we solve that, we get x equals minus 3 over 2. So here's our other intercept, and we're going to label that the x point is minus 3 over 2, and the y is 0 because it's sitting on the x-axis. Okay, so now we've drawn that straight line, and let's label it. This line is y equals 2x plus 3. 2x plus 3. Awesome. Okay. Next, we've got number D. And D is y equals minus x minus 1. Okay. So we already know that our y-intercept is minus 1. So let's draw that in. Our y-intercept is minus 1. Okay. We also know that the gradient of the line is minus 1. So m equals minus 1. And what does that mean? That means that for every time x increases by 1, y is going to decrease by 1. So let's start at our y-intercept point, which is minus 1. And we know from our gradient that when we increase x by 1, y will decrease by 1. So let's increase x by 1 again, and y decreases by 1 again. And this gradient also means that if we decrease x by 1, y will increase by 1. So if we go there, we're going to decrease y by 1. And there we go, we've got enough points. Grab your ruler and draw your straight line, draw your straight line through all of these points. Okay, my straight line sucks, but you'll use a ruler, so you'll be fine. Be nice and accurate when you do this work, it'll help. Y equals, we just label it, y equals minus x minus 1. And remember here they also said show your intercepts, indicate your intercepts, okay? So our y-intercept is negative 1, so we can label this point here. We label this point, okay? The x value of the point is 0 because it's a y-intercept, and the y value is minus 1. You can see it from the graph and from the equation. Here from the graph we can actually see that the x-intercept is minus 1, but let's just solve it to be sure. So x-intercept, let y equal 0. So we've got 0 equals minus x minus 1. Take the x across, x equals minus 1. Okay, so therefore this point is getting very messy to label. This point over here is the point x equals minus 1, and because it's an x-intercept, y is 0. Okay, and there you go. That's question 29 done. Oh, it's not. I almost missed this. They also say, give the domain and range of each line. So on top of all of this, they also want your domain and range. Okay. So the domain is all of the x points that that a line spans, and a range is all of the y points that this thing is going to span. So let's start off with line A. Let's do the domain. Okay, so the domain, we look at what x points this thing covers. And do you see that if we look at the line x equals 2, do you see that it only ever sits, it's only ever going to sit on x equals 2, and that's it. So the domain is 2, 2, 2. Okay. We could also write this as x is an element from 2 to 2. Okay. Now, I need to just take a quick aside and talk about domain and ranges here and how we notate them. Okay. We can write the domain, for example, x is an element of, we can use square brackets or we can use round brackets. We can also use a square bracket there and a round, or a round and a square. The square bracket means inclusive. So if you're using square brackets, you're saying that the domain includes points A and B. If you're using round brackets, you're saying that it includes all the numbers right up to A, but not including A, and all the numbers up to B, but not including B. If we wrote it this way, it would say it starts at A and goes all the way right up to the number before B, but doesn't include B. And if we wrote it this way, it says it starts at the number just after A and goes all the way up to B and includes B. So square bracket means inclusive, round bracket means exclusive, which means it'll go all the way up to that number, but not including it. Okay. So here, for the domain of this line x equals 2, it includes 2. So x is an element from 2 to 2. Range. Okay. Y is an element. And if we look at the line x equals 2, do you see that it goes all the way down to negative infinity and all the way up to positive infinity? So y is an element from negative infinity to infinity. Why did I use the round brackets or the exclusive brackets? Because you can never reach infinity. Okay, so whenever you use infinity, you have to put a round bracket. There's never a square bracket by infinity. Okay, let's move on. Line B. Let's look at the domain. Okay, domain. Do you see that? So the domain is the x points. And if you look at the line y equals 3, it goes all the way to negative infinity, all the way to positive infinity. Okay, so x is an element from, and once again round brackets with infinity, from negative infinity to infinity. The range, y is an element, okay, of, and if we look at the y, do you see that it sits on y equals 3 and it never moves away from y equals 3? So y is an element from, and it includes 3 because it's sitting on the point 3. So from 3 to 3. Okay. Line C. Do you see that line C, if we look at it, it starts all the way down at negative infinity on the x, you see, because if we keep going that way and following the line, it's going to carry on to negative infinity on the x, you see. The x keeps increasing, increasing, increasing. And the same story in the positive direction of x keeps on increasing as we follow the line. It just goes on and on forever. So, for the domain, x is an element from negative infinity to infinity. The range, y is an element. So let's look at the y points of this line. If we look at this line, do you see that y starts all the way down at negative infinity because it just keeps going. And it increases all the way up to positive infinity. So y is also an element from negative infinity, negative, to positive infinity. Okay. And our last one is D. Okay. We look at line D. Look at the x points for the domain. If we follow the line, x keeps increasing. It goes all the way to negative infinity. And if we go here, x also keeps increasing. So it's all the way to positive infinity. So the domain, x is an element from negative infinity to infinity. Range, okay, y is an element. Now, if we look at the y points as well, we start here. Do you see that y goes it just keeps increasing. It goes all the way up to positive infinity. And y also decreases all the way to negative infinity. So y is an element from negative infinity to infinity. Cool. Okay, we're almost at the end of this exercise. Thank goodness. It's been a long one. Okay, number 30. They say, write the following lines. Write in gradient form. Okay, they say write the following lines in gradient form. We've done so many of these. I'm going to do both of them, but I'm not even going to talk. I'm just going to quickly write out the solution for you so you can see what I'm doing and how I'm doing it. So the first one is x over 3 plus y over 4 equals 1. And b is 3y minus x plus 1 equals 0. And when obviously they're talking about gradient form they want it in, so it's mx plus c form. Okay, so I'm just going to quickly work these out for you just so you have the solutions, but I'm not going to say what I'm doing because I think you know by now what's going on here. So, sorry about that. We want to get y by itself on the left hand side if you look at the gradient form. So okay, and here, same thing, just arrange it to get y by itself. So, and there you go, question 30 done. Okay, question 31. For question 31, looks like quite a long one. Let's see how it goes. And this is the last question in the exercise. Find the equations of the lines, then draw the lines on a single graph paper and state which one is continuous and which one is discontinuous. Okay. So first, I'm going to break it up into parts. So first they say find equation of lines. Okay, so let's start with A. They give you the following information. It's a line through the point 3, 4 with gradient 2 over 3. So we're given a point and a gradient, so we use point gradient form. Y minus y1 equals m into x minus x1. And we know this is x1, this is y1, so y minus 4 equals m, which is 2 over 3, into x minus x1 is 3. Okay, and then I'm going to simplify this very quickly. So y equals 2 over 3x, just multiplying out. minus 2, and I'm going to take that 4 across, plus 4. Okay? Equals 2 over 3x plus 2. There you go, you've got the equation of line A. Let's do the equation of line B. Okay, so let's do the equation of line B. Okay, for line B, they give you a line parallel to the line, so line parallel to y plus 3x equals 4, and passes through the origin. They say it passes through the origin, which means it passes through the point 0, 0, because the origin is the point 0, 0. Okay, so this is pretty much useless unless it's in gradient form, because we want to get the gradient, because they've said that our line is parallel to this line. So let's get it into gradient form, which is y equals minus 3x plus 4. So now we know that our gradient is, because the lines are parallel, we know that m is minus 3. Okay? And we've also got a point, because it passes through the origin, so the point is 0, 0. So we're going to do the exact same thing as here. We've got a gradient and a point, so we use point gradient form. Y minus y1 equals m into x minus x1. Y minus y1 is 0, so I'm not going to write it. M is minus 3, x minus 0 again. So x. So that is y equals minus 3x. Okay? There's the equation of our second line. Okay, let's do C. C says a line perpendicular to y equals 3x. So perpendicular to the line, y equals minus 3x, and passes through the point 2, 3. Okay. We know that if our line is perpendicular to that line, when lines are perpendicular, m1, m2 equals minus 1, right? And we know that m2 is minus 3, so m1 times minus 3 equals minus 1, so m1 is equal to negative 1 over minus 3 is 1 over 3. And we've also got our point, which is 2, 3. So this is going to be x1, y1. And once again, we've got a gradient and a point now. So point gradient form, y minus y1 equals m into x minus x1. Y minus y1 is 3. Y minus 3 equals m, which is 1 over 3, into x minus x1 is 2. So x minus 2. Okay? And then we multiply out and we'll have the equation of our line. We just simplify it to gradient form. So y equals 1 over 3x minus 2 over 3 plus 3. Okay, equals 1 over 3x. Minus 2 over 3 plus 3 is, and I'm lazy, so I'm just going to pop it into my calculator. As you should if you're not 100% sure, just pop it in the calculator. And that is plus 7 over 3. And there you go. So we've got the equation of line C. Let's do line D. Okay, line D says a line parallel to x over 2 plus y over 4 equals 1 and passes through the point 0, 1. Okay, so once again, in order to know the gradient of this line, let's get it into gradient form. Okay, so gradient form, we need to get y by itself. So we're going to ditch this, we're going to get rid of this denominator that's sitting under y. So to do that, we multiply the whole equation by 4. So we multiply through by 4, which gives 4x over 2 plus y equals 4. Okay, which simplifies to 2x plus y equals 4. Now we get y by itself, y equals minus minus 2x plus 4. Okay, and now we know that our line is parallel to this line, so our gradient is the same as that gradient, so m equals minus 2. And once again, we've got a gradient, we've got a point, so point gradient form, y minus y1 equals m into x minus x1. So y minus y1 is 1 equals m, which is minus 2, into x minus x1 is 0, x minus 0, and then we quickly simplify. Y equals minus 2x plus 1. Okay, there's the equation of line D, and we've got enough space for line E. Yay. Okay, so line E. A line through the pairs of points 1, 2, and minus 3, 5. Okay, so what are we going to do here? We're going to use that 2-point form. And I need to, there we go. So we're going to use the 2-point form equation, and that equation is y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. Okay, and once again we can choose any points as any ordered pair as 1 and the other ordered pair as 2, but I'm just going to do it from left to right. So we've got x1, y1, x2, y2, and then we're just going to substitute in. So x1 is 1, y1 is 2, x2 is minus 3, y2 is 5. So y minus 2 over x minus 1 equals 5 minus 2 over minus 3 minus 1. And we're going to simplify this and get it into gradient form. So y minus 2 over x minus 1 equals 5 minus 2 is 3 over minus 1 minus 3 minus 1 is minus 4. Okay, then we're going to take our denominator across to the right, because we want to get y by itself to write this in gradient form. So y minus 2 equals 3 over 4, negative 3 over 4 into x minus 1. Okay, and multiply out and simplify. So y equals minus 3 over 4 x plus 3 over 4 plus 2. Okay, because I took the 2 across. And let's finally finish this one. Y minus 3 over 4x. 3 over 4 plus 2 is equal to 11 over 4 plus 11 over 4. Okay. Alright, so now we've solved the first part of the question for all of these. We know that, so we've got the equations of the lines. The next instruction says draw the lines on a single graph. Yay! So we're going to draw the lines. Okay, so let's quickly draw ourselves. I think I'm going to zoom out for this so that we can see more of the stuff. Okay, that's a bit too far maybe. Okay, there we go. So now we can see most of the equations at least. So let's draw ourselves some graph paper here. Sorry, draw some graph paper. Okay. Generally, when you draw the lines, it is important whenever you drawing lines or graphs, for that matter, drawing any function, things you must do: label x and y axis, label x and y intercepts of each line, and label each line. Okay, I'm not going to label the x and y intercepts here because they didn't ask for it specifically, but you should, just to be safe. And I've shown you how to label the x and y intercepts in previous examples. Okay, so, but we do need to label our x and y axis. So this is y, and this is x. Let's give it 1, 2, 3, 4. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. Minus 1, minus 2, minus 3, minus 4. Okay, so now we've got our little graph paper here, and let's start off with line A. So we'll do that one in red. Y equals minus 2 over 3x plus 2. So we already know that our y-intercept is 2, because we know that from the equation, and we know that our gradient is 2 over 3, which means if we increase x by 1, y will increase by 2/3. So it'll be there. Another way to do this plotting would be to actually generate a few ordered pairs. So, for example, let's choose x equals 0, x equals 1, and x equals minus 1. For a straight line, you don't need to generate any more than 3 points. It's really pointless to do that. So let's generate ordered pairs. So our ordered pairs are going to be minus 1 and y, which we haven't found yet, 0 and y, and 1 and y. Okay. So pop these into your calculator and you'll get the y points. So basically, substitute in -1 for x and get the y value. So for the first one, we've got 2 over 3 x, which is, x in this case is minus 1. So 2 over 3 times minus 1 plus 2. So our y point is 4 over 3. Okay. Next, we're going to substitute x equals 0. So y equals 2 over 3 times 0 plus 2. So y is going to be 2. For x equals 1, we substitute in 1 for x. So y equals 2 over 3 plus 2. 2 over 3 times 1 plus 2. So 2 over 3 times 1 plus 2 is 8 over 3. And then we're just going to plot those points. So here I'm estimating. You should be more accurate when you work with your ruler. So we've already plotted the point 0, 2. At x equals 1, we've got 1 and 8 over 3. So that's that point. X equals minus 1, we've got minus 1 and 4 over 3, which is somewhere here. So once you've drawn those 3 lines accurately, you're just going to put your line through those 3 points. And remember to label your line. So this line is y equals 2 over 3x plus 2. Okay. For our next line, we're going to generate our points once again. So y equals minus 3x. And let's use the same x points. So we're going to go minus 1, 0, 1. These are generally 3 very good points to use when you're plotting a straight line graph. And as I said, usually you should solve for this x-intercept as well. Okay. Don't read it off the graph. Solve for it by letting y equal 0 and label the x-intercept with an ordered pair and label the y-intercept with an ordered pair. Okie dokie. But we're on B now. So substitute in minus 1 for x. So y equals 3. Negative 3 times minus 1, which is equal to 3. Substitute 0 in for x. If we substitute 0 in, minus 3 times 0 is 0. Substitute 1 in, y equals minus 3 times 1, which is minus 3. Okay, so there we've got our 3 points. So let's quickly plot them. Minus 1 and 3. So x equals minus 1, y equals 3. So that's there. 0 and 0 lies here. 1 and minus 3 lies there. And we can draw our line through those points. And remember to label your line, which is y equals minus 3x. And once again, indicate your x-intercept and y-intercept on your graph. Just for safety, even if they don't ask for it, if you have time, just label it, because you know they might be looking for it and not ask for it. Okay, let's do our third line here. 1 over 3x plus 7 over 3. So I'm just going to do 2 points here, and 2 points is sufficient for a straight line. So let's just do x equals minus 1 and x equals 0. So substitute in minus 1. That gives minus 1 over 3x plus 7 over 3. So minus, or it gives, 1 over 3 times minus 1 plus 7 over 3. So 1 over 3, and I'm popping it into my calculator, as should you be. 1 over 3 times minus 1 plus 7 over 3, which is equal to 2. There's our first point. And then we're going to substitute in our second x value, which is 0. 1 over 3 times 0 is 0 plus 7 over 3. So our second point is 7 over 3. So let's plot those. Minus 1 and 2 is this point over here. Okay. 0 and 7 over 3. 7 over 3 is just above 2, which is more or less here. So there we've got our 2 points, and we can draw the line. Okay, so there's our next line. And I think that's actually sufficient. I think we've drawn enough lines here for you to get the point. You're free to sketch these by yourself. And make sure that you get the right graphs. I'm sure you will. Just remember, drawing graphs, here are your guidelines. And then, just to end off the video, I want to explain to you how to get your ordered pairs using your calculator automatically. There's a very nice way of doing it. I'm just quickly double checking that I've sketched all of our graphs correctly so long. Yeah, everything looks fine. Okay. Now, how to do this on your calculator. So, let's take this equation as an example. So, we're going to use y equals minus 2 over 3x plus 2. So, how do I generate my ordered pairs on the calculator? So, starting from the blank screen, if you press the mode button, which is on the top right of the calculator, then you press number 7, which is labeled table. So, we go mode, then we go table. Okay. And then you'll see, you'll get, your screen will show f of x is equal to. So this is where you're going to enter your function. And you can type in your function exactly as it stands here. So you're going to type in minus 2 over 3. So you press minus 2, the fraction button, and then you put a 3 at the bottom. Okay, then to enter the x, you're going to press alpha and x. So press alpha and the close bracket button. You'll see the red x above there. So there you got your x. Okay, so once again, you're going to press alpha and the close bracket button. And you'll see above the close bracket button, there's the red x. Okay, and then just enter plus 2. Okay. Then you're going to press equals. Once you press equals, it's going to say start. Right? So the start value is your x points. Where do you want to start? Do you want to start at -5 and increase? Do you want to start at 1 and increase? Do you want to start at 0 and increase? So that's the start value. So I'm going to put here start at -1. So you just press -1. You'll see it'll come up at the top left of the calculator, and you press equals. So now you've told it to start at -1. Next it's going to say end. Okay, so now you want to say which x point do you want to end at. So we've already told it start at -1, and let's just end it at 2. So you're going to press 2, and you'll see the word end gets replaced by 2, and then you press equals. So now we've told it where to start, what x value to start at, which x value to end at. And then it says step. Step. So that's saying, okay, I know where my start and end points are, but what values must I calculate in between? So if you set the step value at 1, so if you set start -1, end at 3, and you set the step value at 1, the x values it uses are going to be -1, and it's going to step in ones. So 0, 1, 2, and 3. So this is if you said step equals 1. If you say step equals 0,5, then it's going to calculate all the values, use all the x values between -1 and 3, but with steps of 0.5. So it's going to use x equals -1 minus 0,5, 0, 0,5, 1, 1,5, 2, 2,5, 3. Okay? And that's how it's going to do the calculation. Just take note that the calculator will never calculate more than 10 values. So if you set your step too small, you're going to get some sort of error. So if your step is too small, it's going to say insufficient memory, in which case you must press back and do the whole process again with a reasonable step size. So the step size I'm choosing is going to be 1, which is a nice step size. Okay, and more than sufficient for drawing a straight line is a step size of 1. Okay, so generally a step size of 1 for straight lines is going to be fine. You don't need to step very small for straight lines. And as I said, if you've programmed it so that it's supposed to calculate more than 10 x values, you will get an error. So once you've entered the step, so you say 1 and then you press equals, and next thing your calculator is going to give you a table. So then after you've done this, you're going to end up with a table, and the table is going to have numbers. So it's going to look like this. The table is going to have numbers on the left, 1, 2, 3, 4. Okay, and this could go all the way up to 10, but I've said start at -1, end at 3 with steps of 1. So we're going to, I think I actually told it to end at 2. Let me just check that. I've told it to go from -1 to 1. Let's do -1 to 2 in steps of 1. Sorry. So -1 to 2 in steps of 1. So then it's going to do -1, 0, 1, and 2. Okay. And once again, we're doing this for this function here. So now you're going to end up with a table like this. It's going to say x, and it's going to say f of x. And then the values that the calculator throws out for this function are -1, 0, 1, 2. Those are the x values we told it to use by programming it here. And then the outputs are 2,67, 2, 1,33, and 0,66. Okay. So, what are these values? Well, each row here is an ordered pair. well, this piece is actually the ordered pair. This is just a number. This is just saying the first ordered pair, the second ordered pair, the third ordered pair, and the fourth ordered pair. X and f of x, we know that f of x is y, same as y, so it's an x and y point. So our first ordered pair is -1 and 2, 6, 7. Our second ordered pair is 0 and 2. Our third ordered pair is 1 and 1, 3, 3. And our fourth ordered pair is 2 and 0, 6, 6. And there you go. Your calculator just generated your ordered pairs for you nice and easily. And then you can plot those ordered pairs and draw your straight line. Okay, thank you very much for watching, Chase. Hope it helps. And yeah, this is now the end of the straight line at last. So we can move on to the circle in the next video. Thanks. Cheers.